Now let's talk about something that sounds advanced, but actually makes concurrent programming much simpler. Structured concurrency, currently in its 5th preview in Java 25. Analogy to understand it: imagine if you are managing a kitchen, you assign two chefs for two different tasks. One is preparing pizza and other is preparing coke. So as a good head chef, you don't leave until both are done, right? Once both dishes are ready, you serve them together. That's exactly what structured concurrency does. It runs tasks in parallel, waits for all of them to finish, and lets you combine their results safely. So the core API, that is Structured Task Scope. This feature introduced a new API, Structured Task Scope, which lets you define a scope for running multiple subtasks together. Think of it as manager ensuring all subtasks start, finish, or fail in a clean, predictable way. For example, we are extending the example of the chef's kitchen. Let's say in our main method, we are creating new subtasks using this scope, which is nothing but from StructuredTaskScope.shutdownOnFailure. So we are using Structured Concurrency API that is introduced in API to actually create the subtask, and then join, that is we wait for both the tasks to finish, and then once they are finished, so this is a main thread that has created these two subtasks, now getting their result and joining them, combining them. So here is our quick sample example to define how structured concurrency works. Here both tasks run in parallel. One prepares pizza and other prepares coke. The main thread, that is our chef, waits for both before serving. If one fails, since we are using shutdown on failure, other is automatically cancelled. It's a clean, structured way to handle concurrency. No dangling threads, no manual cleanups, and no hidden error. So what is key takeaway? Structured concurrency helps you treat multiple subtasks as a one logical operation, making concurrent code easier to read, reason about, and maintain. Now, traditionally, we would use an executor service and manage everything ourselves, submit tasks, wait for results, handle shutdowns, exceptions, and the whole deal. But structured concurrency takes care of all that for us. It's like focusing on the business logic and not the thread management. Next up, scoped value, which have now been finalized in JDK 25 after several preview rounds. Quick recap: I have covered scope value in details with demos and examples in my Java 24 feature review video again. But here is a quick refresher. Scope value lets you share immutable data safely across methods or tasks without relying on ThreadLocal. Why it matters? In older Java versions, we use ThreadLocal to store data tied to a thread, like user IDs, transaction IDs, and so on. That worked fine until virtual threads arrived, first previewed in JDK 19 and finalized in JDK 21. Virtual threads are extremely lightweight, and many of them share the same underlying OS thread. This means the data stored in ThreadLocal can leak or behave unpredictably across virtual threads sharing the same carrier thread. Scoped values solve this. They let you bind immutable data to well-defined scope, automatically cleaned up when the scope ends. So, finalization summary. Scoped values were first introduced in JDK 20, stayed in preview from JDK 21 to 24, and now in JDK 25 they are finalized and production ready. And just to clarify, Java isn't forcing you to migrate away from ThreadLocal. The goal isn't to deprecate it. Scoped value is a simply safer and modern alternative, especially suited for structured concurrency and virtual threads. In short, scoped values lets your thread share the context, not confusion. If you have already seen my Java 24 videos, you know how scoped values simplify context sharing. In JDK 25, they are no longer experimental. They are stable, efficient, and ready for production use.